We will now look at the affinity of hemoglobin to oxygen at the level of the lungs as well as at the level of the tissue. So here we have a cyclist performing physical activity while riding the bike. This is the blood of the cyclist at the level of the lungs here, and this is the blood of the cyclist at the level of the tissue. So at the level of the lungs, the blood does not have enough oxygen. So the hemoglobin that is going to the lungs is going to want to get more oxygen. So let's look at this graph. So while resting, these hemoglobins will slowly get loaded with oxygen due to the fact that there is a high partial pressure of oxygen at the level of the lungs because you just breathed in this oxygen. So we see here the increase in saturation of hemoglobin as a function of partial pressure of oxygen. This is the partial pressure of oxygen at the level of the lungs. It is around 13 kilopascals. And then it's going to go to the tissues to deliver this oxygen. At the tissues, there will be unloading of oxygen from the hemoglobin, and this oxygen will go to the tissues themselves, the muscles of the cyclist. At the level of the tissues, we have a partial pressure of oxygen that is 5 kilopascals, so it is very low. It is not enough to support the saturation. It's not enough to support the loading of oxygen onto hemoglobin. The movement of oxygen is driven by the concentration gradient of oxygen. High concentration in the blood, low concentration in the muscles. And the partial pressure of oxygen at the muscles is not enough to support loading. That is why the one-way movement of oxygen from the blood to the muscles is supported, and the back-way movement from the muscles to the blood is not supported. Now, this is all during rest. But we said that the cyclist is performing a physical activity, which is cycling. So let's see what happens when the cyclist is pedaling. This unloading mechanism will happen a lot faster because there's a higher need for oxygen in the muscles now that they are performing physical activity. The same happens at the lungs during pedaling. The loading of oxygen and the saturation of hemoglobin with oxygen will happen a lot faster because this loading is what is going to drive the unloading at the muscles. Since we need the unloading to happen faster, we need the loading to happen faster. So this is the discussion on hemoglobin's affinity to oxygen at the level of the lungs and the body tissues under rest and under physical exercise.